Now let's learn how to differentiate the product of two functions. So we have f of x times g of x, and we want to take the derivative of the product. Again, we're going to go back to the definition. So this is equal to the limit as h goes to 0 of f of x plus h, g of x plus h, minus f of x times g of x divided by h. We want to convert this then into derivatives, and presumably we'll have derivatives of f and derivatives of g. So if we look at the first term, f of x plus h times g of x plus h, we can subtract from that term f of x times g of x plus h, and then we will end up with a derivative of f. And then if we subtract that term, we'll have to also add that term. So let's just see if we can get this to work. So this is the limit as h goes to 0. So we have our f of x plus h times g of x plus h. And then we're going to subtract f of x times g of x plus h. And at the same time, then, we're going to add what we've subtracted. So we're going to add f of x times g of x plus h. And then we have the remaining term, minus f of x times g of x. Okay? And we divide all of that by h. So we've just subtracted and added the same term. But then we see we can factor out of g of x plus h from the first two terms, and we can factor out an f of x from the second two terms. So let's write that. So this is equal to the limit as h goes to 0. So we have f of x plus h minus f of x, and that whole thing times g of x plus h. And then we have a plus, and then we can factor out an f of x. So we have an f of x, and then we have a g of x plus h minus g of x from the second two terms. And then all of this is divided by h. And now we see the derivative here. So we have f of x plus h minus f of x divided by h. That will become f prime. G of x plus h as h goes to 0 becomes g of x. That's perfectly fine. And then we have f of x as h goes to 0 is still f of x. And g of x plus h minus g of x divided by h as h goes to 0 becomes g prime of x. So this whole thing simplifies to the derivative of f times g after we take the limit h goes to 0 plus f times the derivative of g. Okay, so a very nice simplification. So this is the product rule, and you have to remember this. The derivative of the product of two functions is the derivative of the first times the second plus the first times the derivative of the second. You need to remember that. The derivative of the product is the derivative of the first times the second plus the first times the derivative of the second. Let's look at an example of the product rule in action. Let's take the derivative, say, of the product of two functions, and I'll choose a simple one, x squared plus 1 times x squared minus 1. So the derivative of the first here is the derivative of x squared plus 1, that's 2x. The derivative of the second here is the derivative of x squared minus 1, that's also 2x. So this is equal to the derivative of the first 2x times the second, x squared minus 1, plus the first, x squared plus 1, times the derivative of the second, which is 2x. And that simplifies to 2x cubed minus 2x plus 2x cubed plus 2x, which becomes 4x cubed. And that was obtained using the product rule. Of course, we could have done that in a simpler way. We could have multiplied this out first. So we could have said that's equal to d dx of x to the fourth. And then the cross term cancels, and we have a minus 1. And then we can apply the derivative of the constant is 0, so we just have the power rule here. So that's equals 4 times x cubed. So actually, it's easier to do this example by multiplying it out. But we're going to have very complicated functions later that are the products of two functions. And they may be like exponential functions, sine, cosines, etc. And it's you cannot just multiply it out like a polynomial. So let me summarize. In this video, I derived the product rule, and that's something you have to memorize. The derivative of the product of two functions is the derivative of the first times the second plus the first times the derivative of the second. I'm Jeff Chasnov. Thanks for watching, and I'll see you in the next video.